Here's another useful collection class in the standard library, map. Unlike vector, which is just a collection of stuff, things in a map are organized into pairs of keys and values, and then you can look up what value belongs to a particular key. There can only be one value for each unique key. Like the vector, it grows when it needs to. If you add a third, fourth, fifth item, it just keeps getting bigger. And it keeps itself sorted. That way it can find where things belong properly and quickly. Of course, that means it's a little more expensive to add items than just to throw them into a vector, but presumably you're doing this for a reason, and you're choosing your data structure with care. The easiest way to work a map is to just use square brackets. Map name, square bracket, the key, end square bracket equals the value you want to associate with that key. Done. You can create pair objects and add them in as a pair, and you can use the find method to look things up. I'll show you how to do all of them, and then you'll agree that using square brackets is the simplest and easiest. It's all the same internally. If you want to use map in your own code, just remember to include the map header, and of course it's in the std namespace. I'm going to use the same demo solution for maps as I was already using for vectors, and I have these people that I've already created. I'm going to put them into map now instead of into a vector. So here I declare myself a map, and when you declare it, it's a template. You have to say a map of what, and that means what is the key and what is the value. So this particular map, I'm going to map integers to person objects. As you know, people have an arbitrary number, so I decided I would happen to use that for the key. I could have used anything I wanted. So here I'm using the square brackets. People, square brackets, some number, and I'm going to actually use the return value from getNum, equals a person object. And I do that twice using the square bracket notation. And then I'll do it once kind of the slow way, if you will. Create another person who's called third fiction, and notice the number 124. It's in between Kate's 123 and someone's 456. Then I create an object of type standard pair, and standard pair is a template that again takes two types. It's a pair of int and persons, and so I'm calling it P, and I construct it by passing in an int and a person. And then I can call people.insert and pass that pair in. Well, I think constructing a pair and then calling insert and passing the pair in is way more work than just using the square bracket notation. The same thing happens when you do this. Now, this is fun. I'm going to iterate through the map. So it's available for looking things up. Who is person at 123? Who is the person at 124? But I can also just iterate through it and say, show me the whole map. And when I do that, you'll notice that this notation is just about identical to the way I was going through a vector. I call begin, and begin on a map gives me back an iterator. Oh, this is you can understand why I don't want to type with my fingers on the keyboard the types of these iterators. It's an iterator to a map of ints and persons. You don't actually have to type all these characters if you do it, but it's still pretty gnarly, really. This IP is iterator through a vector of person, but especially when you use auto, the code is exactly the same. Call begin. Whatever that is that gives me, that's the iterator I'm using, and I'm going to keep using it, incrementing it as I go, because of course these iterators all have an overload for the increment operator, until I get to the end, so as long as we are not at the end. And then I'm going to dereference the iterator, and you dereference a map iterator the same as you dereference a vector iterator. But a map iterator points to a pair, and the pair has two elements, first and second. So you have a pair of int comma person, first is an int, second is a person. If we had a pair of floats and strings, first would be a float, second would be a string. So here I can just dereference and say, give me first, that's an integer, and you'll notice that the compiler knows that knows that this is a map of ints and persons, and therefore first is an int, while second, and again the compiler already knows this, is a person. So I'm going to call its getName method. And it's a person object, not a person pointer, putting solid objects into this map, so I'm using the dot to get that person object's name. Why don't I let this run down to here? And take a look at the output. Still got the noise turned on in the destructors, so all the copying around of person objects is continuing to happen with map. It's just as copy. Really, the whole standard library is very copy friendly. There are ways to prevent it from copying by creating objects that can only be moved, and you can imagine they have performance benefits for large objects. But you'll see that I created this third fiction object on the stack, and then this is the current contents of our map. 1, 2, 3, 1, 2, 4, 4, 5, 6. It's kept sorted internally. You can also see that by taking a look at it over the debugger. Here's our people. There we go. You can see 0, 1, 2, and they were added in the order Kate, someone else, and then third, but it's kept sorted internally. And this is a pretty good way of looking at the contents of your map. If you need to, of course, you can expand out further to take a look at what first and second. You can expand that and work your way through indefinitely. Pretty easy to use. Just throw things in at their individual keys and then print them all out if you want to, and you can see what order they're in. Of course, usually the reason for keeping something in a lookup table is so you can, look things up. So I can show you some couple of ways to do that. Here's one that uses the find method. And I'm just going to stop debugging so that you can see the types because I'm using auto again. Find doesn't return an element in the map, a pair, anything like that. It returns an iterator. So found here is an iterator very similar to this iterator, and therefore you use it by dereferencing it. In the case of a map, there can only be one hit for a given key. That's the definition of a map. But there are other collections that have a find method where you could say, now find me the next one, now find me the next one, by calling find repeatedly. Consistency from collection to collection is very important in the standard library. The fact that for the specific case of map, you could just return the element itself would kind of mess up people's mental patterns around using the standard library. So these guys return iterators, which you dereference. If you don't want to dereference the iterator, then do it this way. Find returns an iterator, which I dereference, and I get the pair, and I pull out the first, which is the integer, and the second, which is the name. Using the square brackets, looks up the single person object that's at that key, and it's a solid person object, and I just call its .name method to print out the name. I'm putting it in a string here just to show you that you can do more with things than just print them out. Of course, around and print it out, forgive me. So let's run down to here so you can see the output. Actually, let's turn off this constructing, destructing noise. I think the point is probably taken that, yeah, there's a lot of copying, there's a lot of constructing and destructing going on. So we'll run. Just take a quick glance at the output. This part comes from just filling up the map and iterating through it. And then we have the two finds. And they print out 1, 2, 3 Kate Gregory, person at 1, 2, 4 is third fiction. And that makes sense looking through the code. 1, 2, 4 was third fiction, and 1, 2, 3 is Kate Gregory. So either way, you want to work with a map using the find method, making your own pairs and calling insert, or just using the square brackets. It does it, it takes care of it for you. It makes itself bigger, copies everything over, deletes all the old ones. People don't expect C++ to just take care of stuff for you. They expect it to be hard, but the standard library is actually set up not to be hard at all. This is a really easy way to just keep track of stuff for me. My objects are small. I'm done. I've found the collection I need. If your objects ever aren't small, you can drill in to try to find other collections that perhaps work more efficiently for you. Believe me, there are lots of other collections in the standard library besides just vector and map. Take, for example, list. It implements a linked list. Now, vector keeps its elements in a continuous block of memory. When you delete an item from a vector, it copies everything that was after back so that they all still end up continuous in memory. A linked list, they're not continuous in memory. Each element of the list is in its own little piece of memory and has within it a pointer. List happens to be a doubly linked list, so it has two pointers, one to the previous element in the list and one to the next element in the list. So it's super fast to add new elements, but it's slow to traverse the whole list. Now, I want to point out something really important. You traverse the whole list of a linked list exactly the same way you traverse a whole vector. You say, give me an iterator that points to the beginning, keep going as long as we're not at the end, and increment the iterator with the plus plus. An iterator over a linked list knows that in order to increment, it has to traverse the link. An iterator over a vector knows that in order to increment, it just has to move on by the size of the element to the next piece of memory where the next element will be waiting. But those are implementation details. The cool thing about the standard library is they all have begin, they all have end, they all have iterators that have a plus plus. They all have a size and a clear and an erase and other methods that I haven't been able to demo to you yet. They're consistent from container to container. That means when you change your mind about what container to use, you really change a very small amount of code, especially if you've been using auto to declare your iterators, because then it's still auto even though it's an entirely different iterator when it's an entirely different collection. So list is faster if you're adding and deleting and reorganizing, slower when you're traversing. You look at your application. Maybe you add, delete, reorganize all day long, and then at the end of the day you run through the list once to do a report. You'd probably choose to use list. On the other hand, if you sort of set your vector up and then are constantly going through it and you hardly ever change it, well, then I would use vector. If they're small, it doesn't matter. You can choose whichever one you want. Only once you have a performance problem should you try to solve performance problems. But knowing the various performance characteristics, and they're well documented all over the internet, of the different standard collections, lets you make that informed choice. There's more to life than performance. You might actually want different behavior in terms of how you access the elements. So, we used maps so we could look things up by a key value. Queue and double-ended queue support that push and pop. It's not a stack, which is last in, first out. It's a queue. So whoever goes in first comes out first. You push them in at one end and pop them out at the other. And there's a subset called priority queue, which lets you assign a priority to each element so that if you push something in, it might leap up to the head of the queue because it has a higher priority than the items ahead of it. Then there's set. Unlike a vector, set doesn't need to reorganize itself whenever you add or remove an element, and it allows you to keep iterators going even while you're messing with the contents, which you can't do with a vector. It also has some operations available like intersecting two sets to figure out what things are in both sets or what things are in one but not the other. If you're doing those kinds of mathematical operations, set is a great abstraction for that. Multi-map, just like map, except you can have two things at 1, 2, 3 within your map. And there's more as well. These are fully documented. They are literally standardized. There's a committee that shows them all, and it's easy to find out the entire contents. I recommend that you start with the simplest thing that could work, which is probably going to be vector or map. And if and when you become concerned about performance issues, go to the documentation and see what other collections are available to you. The great thing is, because of the way that it was all designed in a standard manner, much of your code will be completely unchanged even when you change your collection type.